Hello dear students, welcome to the practical session of Engineering Thermodynamics. So today we are going to discuss about steady flow energy equation application for heat exchanger, right? So now let's start our session. So first of all, our aim is to find out the heat loss from pipe-in-pipe heat exchanger. It is also known as double pipe heat exchanger. So for illustration, one drawing is attached over here. So as you can see, this is the center pipe through which hot fluid is going in, and through this end hot fluid is going out. Now simultaneously cold fluid is coming in at the outside pipe and cold fluid will leave at this section, right? So what will happen here, you can emphasize, here you can appreciate that this is the parallel flow heat exchanger, right? Both flows are in same direction. Now what will happen if we consider a system over here? Okay, so let's consider a system over here, right? So with respect to this system, if any heat loss is occurred to the environment or not, let's find it out. That is our aim. Okay, so this whole heat exchanger will be considered as our system. Let me remind you, the heat transfer that is occurring from the hot fluid to cold fluid, that we are not calculating. We are calculating the heat loss from the entire system to the surrounding. Okay, so now let's start the experiment.
So this is the setup for pipe-in-pipe heat exchanger. So we will determine the heat loss for this particular setup. So right now the setup is situated for counter flow. So now let's understand how the setup will work. So first of all, water path. So as you can see over here, this particular pipe is nothing but the inlet of hot water. So hot water is supplied from a geyser, right? Here a transparent tube is provided, right? And inside the transparent tube we have another metal tube. So through this metal tube the hot water will pass and the hot water will get out from this particular end. Okay, so now this is the hot water in and this is the hot water out. Here you can see the temperature sensor is inserted over here to measure the temperature of hot water in and hot water out. Okay, now let's talk about the cold water. So cold water is entering from this particular setup, this particular point, right? So it will flow through this transparent tube and it will come out from this particular section. Okay, again to measure the temperature of cold water in, another sensor is located over here, that is at the entry of the cold water, and another sensor is inserted over here, that is at the exit of the cold water, right? So eventually after some time what will happen, you can imagine that hot water will flow in this particular direction and cold water will flow in this particular direction. So heat exchange will take place, right? So we are supposed to find out that how much loss is done from this setup to the ambient. Okay, so that we will find it out. Again over here the hot water flow rate can be measured using this rotameter and the cold water flow rate can be measured using this rotameter. So let's start the reading. Here we have total 4 different temperatures and 2 different flow rates. That's all. We have to note down the temperature first. So temperature 1, channel number 1, that is 42.7, that is for the hot water inlet, right? Then hot water outlet, that is nothing but channel number 3, that is 33.2. Then cold water inlet, that is channel number 4, so that is equivalent to 30.5. And cold water outlet, that is channel number 2, that is 41.9, right? So these are the 4 temperatures. Now the flow rate. So here the flow rate can be measured in GPM or LPH, that is liter per hour. Okay, so let's measure that. So here if you can see that now the hot water flow rate is around 240 liter per hour or cold water flow rate is around 180 liter per hour. Okay, so these are the 4 different temperatures and 2 different flow rates. Now let's move to the calculation part and find out the heat loss.
Now from the experiment, let's start the observation and calculation part. So for double pipe heat exchanger, we know from experimental setup, mass flow rate of hot fluid is 240 liter per hour. We will convert it into kg per second, that is our SI unit for mass flow rate. So that is equivalent to 4 kg per second. Same way for cold fluid, the liter per hour is 180 LPH we will convert it into kg per second, so that is 3 kg per second. Now hot water inlet temperature is 42.7 degrees Celsius, that is 315.7 Kelvin. Hot water outlet temperature is 32.2 degrees Celsius, that is 306.2 Kelvin. Then cold water in temperature is 30.5 degrees Celsius, that is 303.5 Kelvin. And cold water out temperature is 41.9 degrees Celsius, that is 314.9 Kelvin. Now from the SFEE, what we can write is, so m dot h CpT1, that is CpT1 will represent enthalpy H1, right? So m dot h is hot fluid, along with it, which one is enthalpy is, so the one number is representing the hot fluid in, so Cp into T1 plus m dot C Cp into T4, that is what the cold fluid entry, plus heat transfer Q is equal to m dot h Cp T3, so the hot fluid leaving, that is T3, and m dot C Cp T2, that is what the cold fluid leaving, right? So here fundamental for writing the SFEE is what? Fundamental for writing the SFEE is whatever amount of energy or flow is coming inward, that will be on the one side of the equal to sign, and whatever amount of flow is leaving the system, that will be on the other side of the equal to sign. So same pattern is followed over here, plus work done is there, right? So now what will happen here, we can see that we will take Cp as the common on both the sides, right? Further, if we move, then we will substitute the values over here. Cp is 4.184 into 10 raised to power 3 joule per kg Kelvin. Mass flow rate we have, temperature we have. We do not have the work done because heat exchanger will not do any work done. So W will be 0, right? So this way, if the only unknown in the equation is Q, so if we make Q as a subject, then Q is equal to minus 15.9 into 10 raised to power 3 joule, right? So that is minus 15.9 kilojoule. So here negative sign indicates that heat is rejected by the system. So this is the heat loss from the system to the surrounding, right? So that's all. Thank you.